Alright, today's lesson is on dividing rational expressions. If you can multiply rational expressions, then you can divide them. Remember that dividing fractions is just flipping the second fraction and then multiplying. So let's start out with just some basic numerical division. 2/3 divided by 4/5. What we are going to do is always take the second fraction and we're going to flip it. So this becomes 2/3 times 5/4. At this point, we do exactly what we were doing yesterday. We multiply straight across. 10 over 12, and at this point, we simplify. 2 will go into 10 5 times, 2 will go into 12 6 times. This is my answer. So again, division is nothing but multiplication. We just have to do this one flip move first. Okay? So with that said, we're going to work off of what we learned yesterday. So we have the example 14h divided by 15. 14h over 15 divided by 6h. Now remember, anytime we have a whole number, we're going to go ahead and put that whole number over 1 so it doesn't confuse us between the numerator and the denominator. Now, we still have to pay attention to our restrictions. Okay, do I have a variable in either one of the numerators? Nope, in either one of the denominators. Let me say that again. Do I have a variable in either one of the denominators? I don't, so I'm going to say no restriction at this point. I'm going to have to abbreviate that. All right, so I'm going to come on down here. 14h over 15 times, I'm flipping this, 1 over 6h. Now, do you see why it's helpful to put that 1 in the denominator when we have a whole number? Otherwise, we might get confused what goes on top. Now, I'm going to multiply straight across. 14h over 6 times 15 is 90. 90h. Now, I didn't do any simplification first, so let's go ahead and do it now. I see that my h's will cancel out. I also see that at least 2 will go into 14 7 times. 2 will go into 90 45 times. So I'm left with 7 over 45. And that's as far as that will reduce. So I have no restrictions, and this is my answer. All right, let's do another one. So I have 5x squared divided by 10x over 9. Again, I am automatically going to stick a 1 under that whole number. I'm going to look for restrictions. Do I have any variable in either one of my denominators? I do not, so I have no restriction. Now, I am going to flip my second, 5x squared over 1 times 9 over 10x. Now, if we want to, we can go ahead and simplify. I notice a 5 and a 10. I know those cancel. 5 goes into 5 one time, 5 goes into 10 two times. And I know that my x down here will cancel out one of those x's there. So here I've got 1x times 9 is 9x, and 1 times 2 is 2. So I have my answer and no restrictions. Okay, let's go ahead to a third example. Now, this one looks a little bit uglier, but we're okay because we know how to factor. First thing I'm going to do is look at my restrictions. I have got a denominator with 2x plus 1. So I'm going to set that equal to 0, subtract 1 from both sides. I get 2x equals -1, divide both sides by 2. X equals -1/2. That's a restriction. And then I also have x squared minus 9 equals 0. Add 9 to both sides. X squared equals +9. When I take the square root, those cancel. X equals, now here I have both a positive and a negative 3, because negative 3 times negative 3 will also give me positive 9. So I actually have 3 restrictions. X cannot equal negative 1/2, negative 3, and positive 3. Okay, so let's go ahead and go back up here and scoot this over a little bit. X minus 3 over 2x plus 1 times x squared minus 9 all over 6x squared plus x minus 1. Now what I'm going to do, in green, I'm going to come up here and I am going to factor x squared minus 9. Now remember, this is one of our special cases. X squared is a perfect square, 9 is a perfect square, and it is separated by a minus. Square root of x squared is x. That minus tells me that I know I'm going to have a positive and a negative, and the square root of 9 is 3. So I'm going to cross this out. X plus 3 times x minus 3 is what I have there. Then I'm going to come down here. I'm going to tell you if you want to pause and work out the process. I am going to go ahead. I've already worked it out, so we can save a little bit of time. 2x plus 1 and 3x minus 1. Okay, again, we know that we've got to be prepared for our all of our factoring. Okay, so this is nice and ugly. I'm not going to FOIL anything back out, but I get an x plus 3. I have 2x minus 3, so I'm going to go ahead and write that as x minus 3 squared to save some room. I've got a 2x plus 1 and a 2x plus 1 here. 2x plus 1 squared times 3x minus 1. Okay. Let's do one more. So yeah, they can actually end up pretty ugly if you're, if nothing cancels out. Okay, so here is our next example. Again, we have to go for our restrictions, but I'm going to go ahead and factor this denominator here. It will be easier to find the restriction if I factor it first. So x and x, 10 is 5 and 2. Both the signs are the same. They're both going to be plus. Alright, so let's go ahead and find our restrictions. I've got x plus 5 equals 0. Subtract 5 from both sides. I get x cannot equal negative 5. Then I have x plus 2 equals 0. Subtract 2 from both sides. X cannot equal negative 2. Then I have x squared minus 4 equals 0. Add 4 to both sides. X squared equals positive 4. Take the square root of both. Again, I have to allow for both the positive and the negative 2. So what I'm seeing here is that my restrictions are x cannot equal negative 5, negative 2, which is both here and here. Oops. Sorry about that. And positive 2. Sorry guys, I kept hitting my arrow on accident. And now the positive 2 there. Okay, so I still only have 3 because my negative 2 was repeated there. Alright, so let's go ahead and rewrite this. X plus 5 over my factored form, x plus 5 times x plus 2 times, and I am going to flip this, x squared minus 4 over x squared plus 5x plus 6. Now, I still need to factor the second one. So this becomes x and x, plus and minus, because this is our special case, 2 and 2. This one down here, x and x. This tells me my signs are going to be the same and they're both going to be positive. And that's going to be a 2 and a 3. Again, take your time to do the factoring. Alright, so I'm going to see if I can simplify anything. I have an x plus 5 here and an x plus 5 here. So those cancel. I have an x plus 2 up here, and I have an x plus 2 down here. And I see them there just because they're right above each other. I do not have an x minus 2 anywhere. So at this point, I've got an understood 1 here, and I am multiplying it by x minus 2. I have an x plus 2 here, and an x plus 3 there, so x plus 2 times x plus 3. Here's my answer. Here are my restrictions. So as you're seeing that it's the exact same thing as the multiplication, we're just pulling in more of the factoring, and we've got to flip that one. Now remember, we're always going to look for our restrictions first, and then we'll go from there. Alright, email if you have questions.